To the two people tuning into this video, Happy Christmas and a Merry New Year. And on that note, I thought that I would take the time to look back at the year that's now almost over. At least in terms of silly little retro products that I've enjoyed spending time with over the previous year. The first item was a holdover from a previous year. The C64 JoyKEY was created as a joystick for the C64, except it's using Cherry MX switches instead of a traditional stick. New feature for this year's edition is that I simply ran out of buttons for when I'm using it with various adapters that I've been developing for it. While there are too many adapters to even list at this point, the ones that I added over the last year is the NES, as well as a 2-button layout for the MSX computers. My second project for my favorite little computer is the C64 PlayOnTape, a version of the Tapuino. For those that are not familiar with it, it's an Arduino-based solution for replacing the dataset on a Commodore 64. It loads the tapes in real time, just like it did back in the day, except there's no azimuth controls needed. And this is the point where last year's obsession with MIDI started. The previous Christmas I had looked into the original Roland MT32 and found them too expensive to buy. Instead I found out that someone had created the MT32 project. It emulates the Roland MT32 and some other versions using a simple Raspberry Pi, and of course I had to build one. Using the design file from a different project, the Clumsy MIDI, as a starting point, I wanted to work at creating something that was more similar to a stereo system box in miniature instead of a bare looking PCB board as I've done in the past. While the top board can be used as an MT32 by itself, I wanted several other features that I couldn't fit on it. These were mainly moved to the extras board, which is the one on the bottom. It contains a passive audio mixer, some status LEDs, as well as a system for translating the baud rates. For those who don't know, the MIDI transmits messages at a certain baud rate, while standard serial ports don't really match that. So what I've done is that I've added an Arduino to help with communications between a vintage computer only having a serial port, so that it can communicate with a vintage Roland MT32, a real one that is, without anything else in between. Of course I needed to ensure that everything worked, so I had a perfect excuse to import one from Japan. One fun fact about me is that I can't actually play any music. I have no idea how to use a musical keyboard, so I needed something that would play music on the device. This one uses readily available Arduino libraries, and it reads MIDI files from a memory card and just plays them back over the MIDI cable. As you can see, it's just readily available modules that can be bought just about everywhere. The board has some extra inputs and outputs in case I wanted to mod the board later in order to create some other MIDI processing device, but that's for some time in the future. So, how much fun can you have connecting the MT32 up to a vintage computer? Well, not much if you don't have the ports for it. And as every Atari ST owner will tell you, the Amiga doesn't. So I needed some form of adapter. This is the one I created for use with my Amiga 500, but should be usable with similarly sized Amigas. While the board isn't small, it should be easy to build for anyone. Well then, what about the PC, I hear you say? My Sound Blaster doesn't have a MIDI input port or output port. Well, not in that sense, but as long as it's MPU-41 compatible, it has these signals already on your Gameport. All we really need is a small breakout port so that we have something to plug your MIDI cable into. As with the Amiga adapter, I designed this one to be easy to build as well. On the topic of Gameports, I went looking for some sort of MIDI keyboard that I could use with my MT32, and the only thing I could find within my price range was this budget thing. It's the Evolution Mark 7 keyboard. It wasn't exactly meant to plug into MIDI equipment. Instead, it was designed to plug straight into your Sound Blaster instead. But in order to get it onto the MT32, I just needed to add a simple little adapter in between the two. So with all that, what's missing from the bulky MIDI-32? Well, a lot of blinking LEDs, of course. Looking online, I realized that there's something called a MIDI channel monitor. The idea is that when you press a key corresponding to a certain instrument, it will be on a specific MIDI channel. The MT32 originally has 16 channels, so this little module takes care of lighting up a single LED to indicate that there's activity on that specific channel. This design was based on a 90s article by W. Dunchevsky. I think that's how that's pronounced, maybe. What drew me to the article in the first place was that instead of using a microcontroller or a CPU of some kind, it's not using any of that. It's just standard CMOS logic chips from the 90s era. What makes this design especially interesting is that the addition of the electrolytic capacitors on the outputs makes the LEDs glow instead of just flickering on and off like we're used to in modern electronics. And now for something completely different. The exact same thing, except it's now using an Arduino. The reason for the second design is simply that some of the chips took a long time to arrive and I wanted to test everything out. So I ended up designing this Arduino version in the meantime. It was just about now that I was realizing that I was completely stuck on the whole MIDI mountain idea, because it's really looking like a mountain at this point, at least the prototypes. And one of the things that was missing from all of it was a way of selecting audio sources, mainly because my vintage boombox only has a single audio input going into it, so I designed this so that I could simply click a button to switch source. Again, I had started to look at solutions without using a microcontroller, so the switching was done by a single IC, and it has 6 flip-flops with a master reset. Clicking any one of the 6 buttons resets it and latches the corresponding relay for each of the channel inputs. And Yeah, of course it had to be relays. In many ways similar to the previous projects, except now we're switching the MIDI signals instead of the audio. Due to size constraints, we now only have 4 inputs, but that should be enough. The selected input will also be duplicated to 3 different through ports. The reason I designed this one was simply so that I could plug something like an USB-based MIDI adapter into the front of it and have a cable at the back running to a vintage computer. Using the buttons I could then switch easily between the two. One of the through ports would then be run to my MT32, the real one, and the second one to the bulky MIDI-32. For a standard that's 40 years old, 2022 sure became the year of the MIDI for me, but there's also a few other projects I've been working on. For those that didn't see my previous video, the NoiseMaker is simply an Arduino based solution for generating hard drive sounds on vintage computers. So for everyone who's wanted to put some noise back into the old vintage computers that have gone oddly silent due to the replacement of aging hard drives with copper flash adapters and so forth, here's something that plays a recording of the real hard drive instead. What's next on the channel and my workbench? Only time will tell, but the thing I've been working on lately is the RetroPanel. The short answer for what it is actually a megahertz display for older AT style motherboards. In this case, because I couldn't actually find something that wasn't an ATX case, at least not reasonably priced, and so I started building one out of PCBs. It should slot into a standard 3.5 inch drive bay. Because I already had that Arduino on there, it only made sense to try adding some other features. I wanted it to be able to be configured via RS-232. I wanted to be able to use the computer with an ATX power supply instead of an older AT style one. The problem with using the standard cables and then attaching a solid switch to it is that if there's a short on the motherboard, it'll instantly keep turning on and on as long as the short exists. The reason for this is that it isn't respecting the power on signal from the ATX power supply. The last main feature was this display can also be built so that it shows the post status messages from common AliExpress PCI diagnostic cards. And that was my 2022 in terms of DIY. For many reasons 2022 has been uneasy for many, but I sincerely hope that we all see each other in 2023.